Have you ever felt like you're just drowning in a sea of AI buzzwords? Machine learning, deep learning, generative AI, LLMs, it's a lot, right? Well, today we're going to clear all that up. Think of this as your personal, no-nonsense map to the entire universe of artificial intelligence. So let's unfold this thing and figure out where we're going. And hey, if you've been feeling confused, you are in really good company. This quote, it comes directly from our source material, and it's just so relatable. The big realization is that AI isn't just one single thing. It's this huge, vast field of study, and once you understand the basic structure, everything else just clicks into place. So here it is. This is the map that makes sense of all the chaos. Seriously, this one slide is the key. At the very top, the biggest category, you have artificial intelligence. Okay, nested inside of that, you've got machine learning. Then, as a specific part of machine learning, you have deep learning. And it's inside of deep learning that we find the things making all the headlines right now, generative AI and large language models. Let's break down what each of these layers actually means. To really make this stick, let's use a super simple analogy. Think of AI like the entire field of physics. It's massive, right? It covers everything from planets to atoms. Well, machine learning is like a specific subfield within physics, say thermodynamics. It's not a separate thing, it's a specialized part of that bigger field. Okay, so our first major stop on the map is machine learning. When you boil it all down, this whole area is really about one thing: training computers to make smart predictions based on data. Right, so here's the crucial idea. You take a program and you feed it a whole bunch of data to train what's called a model. Once that model has chewed on the data and learned the patterns, it can look at brand new, totally unfamiliar data and make a really good, educated guess or a prediction about it. That ability to go from old data to new situations is the absolute heart of machine learning. Now, within machine learning, there are two main ways to get this training done. The first is called supervised learning. This is where you give the model labeled data. It's kind of like giving it an answer key to study from. The model learns the rules because you've already given it the answers. Then there's unsupervised learning. Here you just dump a pile of raw, unlabeled data in front of it and say, go find someone interesting. The model has to find the patterns all by itself. So here's a perfect real-world example of supervised learning. A model gets fed tons of past restaurant orders. And importantly, each one is labeled with key info. Was this order for pickup or for delivery? What was the bill? And what was the final tip? By looking at thousands of these labeled examples, the model starts to see the patterns and can then predict pretty accurately what the tip is going to be for a future order. Now for unsupervised. Imagine you just plotted all your employees on a chart based on only two things: how long they've worked there and how much they make. No other labels. The model might sift through all that and suddenly discover a natural cluster of people who have a super high income for their short tenure. A fast-track group you didn't even know to look for. It found a really valuable pattern all on its own. All right, let's head one level deeper on our map. If machine learning is our thermodynamics, then deep learning is an even more specific and frankly more powerful technique inside that field. So what actually makes deep learning deep? Well, it all comes down to something called artificial neural networks. Now, you don't need to be a neuroscientist here. Just picture these complex systems with tons of layers, loosely inspired by how the neurons in our own brains are connected. It's this multi-layered structure that unlocks some absolutely incredible abilities. And one of those amazing abilities is a technique called semi-supervised learning. It's pretty much the best of both worlds. You can give a deep learning model just a tiny little bit of that labeled answer key data, and it can use that small sample to make sense of a massive, gigantic amount of unlabeled data. This is a total game changer, especially where getting labeled data is expensive, but raw data is everywhere. A bank trying to spot fraud is the perfect example. Look, it's just impossible for people to manually check and label every single transaction. So what do? As you see in step 1, they label just 5%. Then the model learns the basic signs of fraud from that small sample. Step 3, it takes that knowledge and applies it to the other 95% of data. And the result? A super powerful model that can predict future fraud without needing humans to do all the heavy lifting. Okay, now we're getting to the part of the map that has been all over the news: generative AI. It's a specific branch of deep learning, and the big idea here is a shift from just classifying information to actually creating brand new stuff. This slide really nails the fundamental difference. A standard model, what we call a discriminative model, is basically a judge. You show it a picture, and it tells you, that's a cat, or that's a dog. It classifies. But a generative model, it's an artist. You tell it, generate a brand new picture of a dog, and poof, it creates one from scratch. One is a judge, the other is a creator. This all leads to a pretty simple question, right? When you're using some new AI tool, how can you know for sure if it's actually generative? Well, it turns out there's a really easy test. And here's that test. All you have to do is look at the output. If what you get back is a number, a probability, or just a simple label like spam or not spam, then it's not generative AI. But if the tool creates something totally new for you, like text, an image, speech, some audio, then congratulations, you're working with generative AI. It really is that simple. And this field is just exploding. I mean, we all know the text-to-text models like ChatGPT and text-to-image ones like Midjourney, but now things are expanding like crazy into video, into 3D models, and even into these complex multi-step tasks, like just telling an AI to summarize your entire inbox for you. Which brings us to our final and maybe the most talked about stop on our map, large language models, or LLMs. Let's make sure we put these in exactly the right spot in our new mental framework. Okay, this next part is really important to get right. LLMs and generative AI are both subsets of deep learning. And yeah, they overlap a lot. ChatGPT is a perfect example of both at the same time. But they are not the exact same thing. The key to really understanding what makes an LLM special is this idea of pre-training and then fine-tuning. Let's use a great analogy for this. Pre-training a large language model is a lot like teaching a brand new puppy all the basic commands: sit, stay, come. You're training it on a massive general set of data, basically a huge chunk of the internet, and it becomes a pretty good generalist. It learns the grammar, the patterns, the basics of how humans talk. And then comes the fine-tuning. This is like taking that same clever dog and giving it very specialized training to become, say, a guide dog for the visually impaired. You take that generalist model and you train it more on a smaller, very specific set of data. And that's how it becomes an expert for one particular job. And this happens in the real world all the time. A giant tech company might spend billions of dollars to build a powerful, general, pre-trained LLM. Then, a hospital can come along, take that base model, and fine-tune it using its own private library of medical records and x-rays. And what's the result? A highly specialized AI that becomes an expert assistant for improving diagnostic accuracy. So let's just bring it all back home. We have AI, which contains machine learning, which contains deep learning, which has these powerful branches like generative models and LLMs. This hierarchy, this is your map. It's the mental model you can now use to make sense of any new AI headline or product you hear about. We have covered a ton of ground, moving from this huge, broad field all the way down to the super specific models that are changing our world today. Now, the goal here was never to make you an expert overnight, but to just hand you a reliable map. So the only real question left is, now that you have the map, where in the wild world of AI are you going to explore next?